Hello there guys. Okay, this is video number 2 for Visual Basic for Absolute Beginners, and today we are going to look at some of the fundamentals when it comes to computer programming, and that'll be variables and data types. So variables and data types are used right throughout programming. It helps us to declare different instances, and it helps us to pass values from one place to another. So they are very, very common, and a good understanding of this would help. It's not very difficult, so let's get into this. Hello there guys, and welcome back. Today we are going to cover some of the fundamentals in computer programming, and those are the data types and the variables. So we're going to learn how to declare variables, and then we're going to learn a little bit about the data types. Now in this video we're not going to cover all of the data types. We're just going to look at the top 3 or the top 4 basic data types that we will be using probably throughout the rest of this course. Okay, so to start off, what we're going to do is we're just going to carry on from the previous project. So if you've already closed your project or you have maybe deleted it, all you need to do is just create a new project and stick on those 3 controls. As a reminder, I think we only had a text box, a label, and a button control. You can just drag and drop them onto your form, and yesterday's code we did a hello world example. We did a little bit of a hello world where we typed it in, and we also moved the value from text box 1 to label 1 on the button click event. So what we did is we literally just passed the value from one control to the other. Even though that's great, the only thing is that we won't always have data in a variable, in a controls property. We might have values that is a variable. So how do we declare variables? How do we assign data to a variable, and how do we get the data back? The first thing we need to do is declare the variable, and we do that by saying dim. Dim stands for dimension. It allows us to create a variable and assign a value to it. So when we create the word dim, it actually tells the system that we want to remember a specific value. Now, to remember a value and to recall the value, we will need to give it a name. So the first thing after you declared a variable dim, you will need to give it a name. So in this case, I'm going to say my text. Okay, so my text, can't spell. So my text is the name of the variable. So whenever I call my text, it will bring back the value that's assigned to that variable. So I'm going to say my text as a string. And this is where the data types comes in. As you can see, we have a data type of string, and that means that the system will automatically know how to use that value. If it was an integer or a number, a whole number, it would know how to deal with it. You'll be able to do math with it. Where if you have a string, it's just a random text. It's just characters, and the system would need to know how to deal with it. So by declaring the data type will help the system to determine how to work with this data. So in this case, we have put dim my text as string, but there's a little problem. There's a little green squiggly line at the bottom, and because it's green, it means that something's wrong, but it's not a problem. Okay, it just means that we have not actually assigned a value to my text yet. We've told the system we want the system to remember a variable. We gave it a name, but there's no value. So the moment I go equal, you'll see that squiggly line has disappeared. But now there's a red line right next to the equal mark, and that is because we've said it equals to, but not equals to what. So because it's a string, we have to put it in our double quotation marks, and we're going to assign a value of this is text. Okay, so that's it. That's how we assign a a variable. We just declare a dimension, we give it a name, we tell it what data type it is, and then we are assign the value to that that variable. Okay, now how do we use the variable? Well, in this case, it's very simple again. We're just going to take out the previous code and so we're going to update label 1's text property with my text. As simple as that. So every time we click the button, here we go. So every time we click the button, it should say this is text. Okay. So that is how you declare a variable, and that's how you set a value to a variable. That's also how you can get the variable's value back. But in this case, we're only working with a little bit of text. So there's a huge amount of different types of data types that we can use. So one of the common ones is a string. Another common one is integers. An integer is a whole number. Okay, it means that you cannot have 6.2. It's a full number, and you can do basic math with it. So if you want to do counting, if you want to do keep record, if you want to have indexes, these are the things that you would use. You would use an integer for that. So in this case, I'm going to do a little experiment with you, and I'm going to say dim my value 1 as an integer, and I'm going to give it a number. And in this case, because it's a number, I do not need to put it in quotation marks. So I'm just going to give it a number of 1. I'm going to declare another variable, dim my value 2 as integer, and equals 5. And now what I'm going to do is I am going to do basic math. So in this case, label 1's text property, even though it's text, if I do math and I assign the actual integer value to a text field, it will automatically convert it into a text value. For example, my value 1 plus my value 2 would be the result of that will be the value that gets placed into label 1's text property. Okay, let's give it a quick run, and maybe that will be more beneficial than my explanation. Here we go. Okay, so what it did, it gave us the value of 6, which means that it actually added the two numbers together, and it then converted the integer value of 6 into a text value so that it can apply the value to the property. It's very, very simple. You don't need to go and change it from an integer to a text. It automatically does that for you when you specify where you want to place it, because the text value can only accept text, and therefore if you produce anything other than text, it will then convert it into text for you. Okay, here is another example. I'm going to change my integers to strings. Now, even though I said it's a string, it does not give me any error when it's looking at a value. But to read it as a string, we have to put our quotation marks in. Okay, so what would happen if I run this? Let's have a look. It's giving us 15, but why is that? Well, it's because it does not know how to deal with strings. It will literally just concatenate the two values, because value 1 was the value of 1 and my value 2 was the value of 5. It took 1 and 5 and just joined them together. So that is how it deals with strings. It can't actually do the math. It won't convert the string into an integer because it won't know what it is. It wouldn't know what data type it is. but we can actually tell the system how to do that. For example, if I went and said C int plus C int, it will now take this text value, which is my value 1, and it will convert it to an int. The C means convert, and the int means integer. So in this case, it will convert the text into an integer. It will also convert my value 2 to an integer, and then it'll add the 2 up and produce it back. It will convert it back into a text into the label. Very, very exciting, very long-winded, but let's see it work. There we go. So now we have the number 6. Okay. Now, let us do another quick experiment. Okay, so our quick experiment is going to be to do exactly the opposite. Instead of converting it into an integer, we are going to convert an integer into a string. Now, all we need to do is take our string values here, convert them to integers. Oh. And I'm going to remove the quotation marks, and instead of to a C int, I'm going to go C str. Now you can see the moment I put in the C, you can convert to a byte, short, string, into any type that you actually want. And if these are not enough, you can actually go and look for other data types to convert them into. You can even take a data type that does not have a specific data type to convert them into, and you can create your own function to change them. So I'm going to do the same with my value 1. I'm going to convert that to str, and even though I'm putting a plus symbol here, let's see what happens. And there we go. 1, 5. Again, the reason why it's giving us the 1 and the 5 is because the 1, even though we declared it as an integer, we are converting it into a string, and then we are converting value 2 as a string as well, and that's why it doesn't know what to do with them. They're not numbers. The system can't add strings together. It's like saying what is A plus B. It doesn't know, so it'll just concatenate the two values together. Okay, so data types. If you're looking for more information about data types, Microsoft has a fantastic set or a list of all of the data types that you ever would want in your life. You probably wouldn't use half of these ever, but if you do, then here's a list and an explanation. We've just covered some of the basic stuff. So for example, an integer we've covered, and that is a number from a negative 2,147,483,648. Yes, I can read numbers. Up to a positive value, and it's assigned integer. All right, and we've done a string, which is of any variable length, 0 to approximately 2 billion Unicode characters. That means a massive amount of characters. So those are the two most common ones. And like I said, an integer is a full number. You can see there's no decimal places here. There's no decimal places here. It's just a full value. If you needed a decimal place, you can either go for a decimal or a double. So in this case, a double is an 8-byte character, and it goes from -4 and I don't know how many. So I think there's 8. 2, 4, 6, 8. A lot of characters behind that. Now you can actually say, when you say double, I want to say a double where there's a figure and then how many characters at the end. Similar to the decimal, for example, you can go from a positive to a negative value of, I'm not even going to attempt to read that, but all you need to remember is that there is a set limit of characters. So for example, you can have this number with 28 places to the right of the decimal. So you can have one number and 28 places at the back of that as a decimal. And then you can do currencies, you can do fractions, you can do everything else that an integer won't do. Okay, so if you need more information, what I'm going to do is I'm going to take this link, I'm going to add it to the description in this video, so please go and have a look if you need more information there. Another very common data type is a Boolean. A Boolean is literally just true or false, yes or no, 1 or a 0, and you most commonly use it when you want to verify that something is actually true or false. For example, go and look in this folder. Is this this file here? Is there a file named my text document or whatever? And it will then say yes or no, and that'll be a Boolean, true or false. Another thing is the date and time, very common data type. Again, once you declare the data type, it knows how to use them, and we're going to go through some of these data types as we go through the course and learn how to use them, especially when we start dealing with controls, because there's specific controls for data types. For example, the date time picker that will allow us to pick dates and format dates. Decimal places, we can use mask text boxes, and when we do functions, we're going to do functions that return booleans, for example. So all of these data types are going to be very important in the near future. So it's at this time that I would like to say that if you find any of this information helpful, please subscribe, click on that bell notification, because it'll only help me grow my channel. And for that, I thank you, have a good evening, and I'll see you in the next video. Cheers.